Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos, and do not forget to like and share the videos. In today's video, we'll be learning about the continuation of this chapter, light, reflection and refraction. This belongs to the physics part, and this is the chapter 1 of physics, but chapter 10 of NCERT. Our topic for today is representation of images formed by spherical mirrors using ray diagrams. We'll be learning about the ray diagrams and particularly about the important paths taken by the rays after it gets incidented, how it gets reflected back in today's video. So first of all, we know that light travels in the form of rays. Light travels in the form of rays. But what is a ray? Ray is the direction or the path along which light travels. Okay, the direction or path along which light travels is known as ray. Alright, now we'll be learning about particularly about these rays, the important paths taken by the rays, how it gets incidented and how it gets reflected back. First of all, we learn how to represent images with the help of spherical mirrors. We use ray diagrams. We use ray diagrams to represent the image formation by spherical mirrors. Now just consider an object. Let this be my object. It is extended from a spherical mirror. Let me take a concave mirror. For a concave mirror, I had already told you in the previous videos that the reflecting surface is curved inwards. So which should be my rough surface? Outwards. This is my rough surface where no reflection takes place. This is a concave mirror. Alright, this is my extended object. This is the object and it is of finite size. It has its own shape and its own size. It has a finite size. It is placed in front of this spherical mirror. It is placed in front of the spherical mirror, the concave mirror. Now, each small portion of this object, each small portion, every single dot or every single point on this object acts like a point source. It acts like a point source. Each point acts like a source of ray, and from each point a number of rays are generated. A number of rays are generated from each point. But to represent image formation by spherical mirrors, we cannot take all the rays from, suppose from this point, so many rays generate. Again, if I take this particular point and so many rays generate. Now, you see my ray diagram becomes so messy. You cannot understand what is being drawn, what I am trying to express. Nothing can be understood. So, for the clarity of ray diagram, any two rays are considered. Any two of the following, whatever I am going to teach, are going to be considered. So, let me proceed now about the important path rays taken by the rays. First is a ray. Okay, let me first explain with the help of a concave mirror. Then I'll go with a convex mirror. Okay, this is my concave mirror. This is the rough surface. Always after drawing the mirror, do not forget to draw the rough surface. This is my concave mirror. This is the pole P, and here is my center C. Then I have my principal axis which passes through the center of curvature and the pole. Alright, now a ray which is parallel to the principal axis. This is the principal axis, and the ray should be parallel to principal axis. Parallel to the principal axis. It incidents on this concave mirror. Okay, now it is getting reflected back, right? It should get reflected back. So after reflection, this is my principal focus. After reflection, it will pass through the principal focus of the concave mirror. A ray parallel to the principal axis after reflection will pass through the principal focus of the spherical mirror. In case of convex mirror, what happens? This was the diagram of the concave mirror. Alright. Now convex mirror, let me take. This is the convex mirror. Which is the reflecting surface of convex mirror? It is outwards. It is curved outwards. So where should my rough surface be? Inwards. So I draw my rough surface over here. Okay, this is my convex mirror. Now I take this to be the pole. Here is my center of curvature, and in between the pole and center of curvature lies the principal focus. Now I draw my principal axis. Okay, this is the principal axis. Now a ray which is parallel to the principal axis. Okay, a ray which is parallel to the principal axis incidents on this convex mirror. Okay, it incidents on this principal, it incidents on this convex mirror, and then it gets reflected back. It gets reflected back like this. Since it is a diverging mirror, since convex mirror is a diverging mirror, you see that after reflection the ray gets diverged this way. But it appears to be coming from this point. This is the principal focus. So a ray parallel to the principal axis after reflection appears to diverge from the principal focus in case of convex mirror. It appears to diverge from this point. This was the first path ray. Now second one. I take a concave mirror again and I draw the rough surface. Here's the pole of the mirror. Here is the center of curvature. Alright. Then I draw my principal axis. In between the pole and the center of curvature lies the principal focus. Now the second important path taken by the ray is that a ray which passes through the principal focus. The incident ray passes through the principal focus like this. It incidents this way. The ray gets incidence this way. It passes through the principal focus of the mirror. Now, after it gets reflected back, it emerges parallel to the principal axis. This is the principal axis. After reflection, it gets emerged parallel to the principal axis. This is the reflected ray. This was in the case of concave mirror or converging mirror. Now in case of convex mirror, okay, I take my convex mirror to be like this and the rough surface is over here. Inwards is the rough surface. Here is the pole. This is my center of curvature. A line, an imaginary line passing through the pole and the center of curvature is the principal axis. In between the pole and center of curvature is the principal focus. Now, a ray, an incident ray that appears to be directed towards the principal focus. Okay, my incident ray is something like this. Okay, it appears to be directed from the principal focus. This is my incident ray. it is striking the mirror. It gets incidented on this convex mirror. Now after reflection, what happens is that it emerges parallel to the principal axis. It emerges like this. This is the reflected ray. In case of convex mirror, a ray that is directed towards the principal focus of the convex mirror, after it gets reflected back, it emerges parallel to the principal axis. Now the third one. The third one is, I take a concave mirror first and I draw the rough surface. Then this is my pole. Here is the center of curvature. Then this is the principal axis. This is the principal focus. Now a ray, an incident ray that passes through this center of curvature. The incident ray should pass through the center of curvature. Okay, I take this to be my incident ray and it passes through this center of curvature. Okay, after reflection, retraces the same path or is reflected back along the same path. It gets reflected back in the same way like this. If a ray incidents through this center of curvature, after reflection it gets reflected back along the same path. It retraces the same path. This is in case of concave mirror. Now in case of convex mirror, what happens? This is the convex mirror. This is the rough surface. Since no reflection takes place here, I draw the oblique lines over here. This is the pole. This is the center of curvature, principal axis, principal focus. Alright. Now a ray which appears to be emerging from this center of curvature. Alright, it appears to be emerging from here. This is my incident ray. After incidenting, again it retraces back. After reflection, it retraces back along the same path. It incidents on the mirror and it appears to be coming from here. So after reflection, it retraces back the same path. This is the incident ray. Again another reflected ray, it retraces back the same path in case of convex mirror. Now the fourth and the last one, another path taken by the rays. Fourth one, I take a concave mirror and draw the rough surface. I draw the rough surface, then I mention the pole, center of curvature, then my principal axis and the principal focus. Alright, a ray which incidents obliquely to the principal axis, not parallel to the principal axis, obliquely, this way. You know oblique lines, right? Like this, slanting lines. So a ray which incidents obliquely to the principal axis like this. This is my incident ray. After reflection, what happens? It is reflected back obliquely. It incidents obliquely and it is reflected back obliquely. Here angle of incidence, this is the angle of reflection, they are equal. Here this is the normal, principal axis is the normal at the pole, and here this is the angle of reflection, sorry, here this is the angle of incidence, this is the angle of reflection. In all, even in the previous diagrams which I showed you, even there the incident ray is equal to the the angle of incidence is equal to the angle of reflection in all cases, but here it is clearly visible. Now in case of convex mirror, the convex mirror is like this, and this is the rough surface of the convex mirror. This is the pole, the center of curvature, principal axis, principal focus. Now I told you that the ray incidents obliquely to the principal axis. That means it incidents like this. This is my incident ray. After it gets reflected back, it reflects back obliquely again. This is the reflected ray. This is the incident ray, reflected ray. Again here you can see this is the angle of incidence, angle of reflection. It's clearly visible that they are equal. Now in these cases, in all the above cases, the law of reflection is followed. I taught you the laws of reflection, right? The laws of reflection. In all the cases, in all the four cases, the laws of reflection are followed, and in all the other points also, at the point of incident, the incident ray is reflected in such a way that the angle of reflection is equal to the angle of incidence. In all the cases it is applicable. If this is followed, the laws of reflection are followed, and even angle of incidence is equal to angle of reflection. Even this is a part of the law of reflection. Now when you represent images formed by spherical mirrors using ray diagrams, you can consider any two rays, any two of the rays that intersect can be used to denote that the image is formed over here. For that reason, I taught you these 4 points in the beginning itself, so that you do not face any kind of difficulty when you start drawing ray diagrams and when you start representing images formed by the spherical mirrors using ray diagrams. You can take either 1 and 4, the first one and the fourth one, or the first one and the second one, but the two reflected rays should intersect at a point. Only then you can show that the image is formed over here. You can understand more clearly when I teach you the image formation by spherical mirrors in the upcoming videos. If you have any doubt, do ask me in the comment section, or if you want me to make a video on a particular chapter, even that do let me know in the comment section.